Good evening students, good evening to you all, and this class is a revision class on the subject of applied physics. In this class what we will be discussing is, we'll be discussing on some of the important topics and the respective videos available on those topics, and what are the problem areas in each particular unit out of the 5 units. Now just before I start anything, I would show you one paper, actually the last exam paper which I have here with me. Just give a minute for me so that I would show you that one, that exam paper. So that was actually held most recently. So that's a supplementary paper for R18 under R18 regulation. And I think this is the one. Yes, I'm opening it now, and as you can see here, this is the one that this is JNTUH first year first semester examination, supplementary for first semester applied physics people, just held possibly on 8th or 9th of November. Now what were the questions given? Let me talk about the pattern of the exam. The exam pattern would be slightly different from that of what you have written so far. I think you might be knowing because you have written an exam today. So it would be consisting of 8 questions, out of which you have to write 5, each one carrying 15. Now there will be 2 particular questions, 2 parts. So one would be for 7, one would be for 8, and so on. This is how it has appeared. We are not very sure this would be the pattern that we are going to get to day after tomorrow for our exam or not, but possibly this is the case. Now let us check here. The first question is from the first unit, second question is also from the first unit, third question is from the second unit, fourth question is from the second unit, fifth question is from the third unit, and then sixth question is from the fourth unit, seventh is also from the fourth unit, eighth question is from the fifth unit. So did you understand the pattern here? Now let me tell you one thing. So there are 3 easy units that you have in this particular syllabus, one of which is the 4th unit, where you will be having lasers and optical fibers. Quite easy to comprehend and quite easy to interpret as well. And now coming to the concept of the first unit, if you are good at the first unit, the quantum mechanics, because many colleges have covered the concept of quantum mechanics in their classes before the lockdown itself, so that they'll be well aware of these concepts. So therefore you can opt for the first unit. You can study first unit well. You can answer 2 questions. That is how the pattern is. Study first unit. So you just choose 3 units and study them well. So there are 2 questions coming from the first unit, 2 questions coming from the second unit, which is semiconductors, and 2 questions coming from the 4th unit, which is lasers and optical fibers. So the path is quite clear for us, not to be tensed for any particular thing, because the questions, the pattern is quite simple, but one thing you need to understand here is the time management. You need to manage time. You need to answer those questions, each one for 15 marks in 2 hours time. And here that means, so you will be answering 5 questions in 2 hours. Each question would be having a span of 24 minutes only, 24 minutes. So therefore you need to be very careful in time management, and if you want to get good marks, so you have to answer all 5 questions. And let me tell you, don't think of any other parameter like the university would be correcting and giving easy marks and so on. Not the case, because many of the colleagues who went already for the correction been given strict instruction on the correction. So therefore I would be telling you, if you write well, you will be scoring marks. But for that, just prepare good 3 units. You can have a 4th unit also as a question, but 3 units. So you have time, at least 1 day from here onwards. So have revision. We are going to discuss about some of the topics today in our revision class. So this is all about examination. So 2 questions coming from the first unit, 2 questions from the second unit, and 2 questions from the 4th unit. So you can choose. So you will be able to answer 6 questions. So if you are preparing 3 units, understood? And if you are good at 5th unit, you can also prepare 5th unit or even 3rd unit. Okay, this is how the pattern is. I've shown you the paper. I would just reduce this particular size so to 100% so that you can see the even lesser. So I would make it to 90 so that you can see the entire paper. This is how the paper is. 8 questions in the JNTUH examination. Now can you have a view? Now one of the questions that have come is, what is the importance of quantum mechanics in science? These are generalized questions and this was given for 7 marks. How to answer such question? Now understand, to answer such questions you need to have a brief knowledge about quantum mechanics. So what is quantum mechanics? What is the difference between quantum mechanics and classical mechanics? Now let me tell you, to answer this question we have actually you can go to the our website, so where all the videos are available. I would show you our website, so somehow it actually we missed out on it. So that is Cynohub. Anyway, in our website you will be finding those videos, each particular topic, and so we have topics important for the exam as well. So these are the topics that are, I have framed it for as important. These are the topics that I have touched till now in R18 examinations, right from December R18. But let me tell you, you can choose 3 units, right? So 1, 2 and 4 if you choose. So we discuss more on them. Now talking about black body radiation, the first question here is, what is black body, and explain the spectral distribution of black body radiation. If this is the question, how to answer this question? Now I'm going to this one. So normal our presentation, you would write what is a black body. Black body is a material in which absorbs radiation of all wavelengths incident upon it, and you would write about what is black body radiation. When a black body is heated, it emits radiation known as black body radiation, right? Once you answer this, you will be getting marks. So you need to be precise to the answer. You need not have to fill pages, let me tell you. And diagrams carry lot of importance. Here these 2 diagrams you need not have to draw, because these were the pictures that are being taken from internet. Anyway, they are not the diagrams anyway, so you need not have to draw, right? And then so regarding the spectral distribution, and you would write one more point. So if at all being asked about Ferri's black body, if you are not asked about Ferri's black body, you would move to spectral distribution like this. So this is the graph, the spectral distribution, and you'd be writing the points about the spectral distribution. I have notes with me. I would be opening the notes of the first unit here for you. This is lecture notes for applied physics. So quantum mechanics, what is black body radiation? This is available in our website. Again, let me tell you, the spectral distribution, this is sufficient. This would be for 7 marks, right? If you are asked to write about the laws of black body radiation, there are laws that are being given here. Planck's law, Rayleigh-Jean's formula, Planck's formula. All these are difficult to discuss in one class, let me tell you. But you can have a glance. So since we are sticking ourselves to units say 1, 2 and 4, we'll discuss more on them. So Planck's law, the derivation part. If Planck's law is asked, then only write. So question to question. See, I'm again opening the question paper here. What is a black body? Explain spectral distribution of black body radiation. If you are asked to write that particular question, what you needed to write is, so this particular page. So you need to write what is black body radiation, the first paragraph itself. And see, the second paragraph is not that much important, let me tell you. If you are asked to write about Ferri's black body, then you can write entire thing with the diagram. So or else you can skip down to Lummer and Pringsheim's experimental findings with the graph and these 3 points. That is important, that's it. So this is for 7 marks, let me tell you. So in 24 minutes time, you need to finish one question. Means you have 12 minutes for one part of the question. As we have seen the paper already, the question paper that is like this. So where you will be having 2 particular parts. Now this is how it is. Now derive an so I would go for another question here. The second question is, what is Planck's radiation law? Deduce Wien's and Rayleigh-Jean's formula from Planck's formula. These are in fact given in the notes, so you can have a check in the notes as well. And there are videos. In fact, this is second unit, sorry, I've turned to the first unit. So this is Wien's law, this is Rayleigh-Jean's formula, and after Planck's formula, here in the notes I have not mentioned, but there is a video that so you would be getting in the website where you can derive both Rayleigh-Jeans formula and the the Wien's formula from Planck's radiation law. That video is available in the website, and which would be not more than 10 or 15 minutes, 12 minutes I think to my memory. So you can go through it. And then another question would be from the first unit is photoelectric emission, photoelectric effect. Again, so you have notes as well as what is photoelectric effect. When actually light falls on a metal, you would be having a current produced or current flowing through a circuit that is connected to that particular metal. Now this is what we call it as a photoelectric effect or photoelectric emission. Now this is first invented by Heinrich Hertz. So this is how the circuit would be. There will be two metal plates. So one would be cathode, on which light is made to fall, and electrons would be ejected. These electrons would travel through this particular tube, the entire length of the tube, and reach the anode. And once they reach anode, automatically they would flow in the circuit, and it is quite easy that we will be knowing that there is flow of current in the circuit by measuring current in the ammeter or microammeter that is given. Now the characteristics of photoelectrons depend on 4 parameters. In fact, I should say the kinetic energy and the number of electrons ejected depends on 4 parameters. The potential difference between those two plates, the intensity of incident radiation, the frequency of incident radiation, and photometal used. You will be getting the details with the graphs. Remember, you need to draw the graphs to get good marks. If you don't draw the graph, you are not going to get complete marks. So how much you write? So you draw the graph, understand the concept, and write it. You can even reduce the writing part, but drawing graphs is very essential. So this is about the photoelectric emission, and these are fundamental points about photoelectric emission. 5 or 6 you remember. And then Einstein's photoelectric equation is not required. Suppose you are asked to write about photoelectric emission only, how much you need to write? Let us consider the case here, the question. Explain the concept of photoelectric emission. Explain what factors photoelectric emission depends on. So this is what we have just seen. So this is what is photoelectric emission, you would write down anyway. So this is the part. This is photoelectric emission, you would write. And then you would move on straight away. You need not have to write experimental study. Straight away to these points. So the photoelectric emission depends on these four particular parameters, and you would draw these graphs and you would write something about each particular graph. So the importance, the effect of potential difference, effect of incident radiation, and then frequency, and then photometal, and so on. This is how you do it, right? So this is about the photoelectric effect. Compton effect, if it is asked, then automatically you need to derive an expression for Compton shift. That is there in the notes. Just have a go through. And there is a video too. I would show you a video in our website. Just give me some time. So I will go to that one and I'll show you. And then yeah. So this is about Compton effect. So that notes is available. You can have a go through. And then de Broglie concept, dual nature of radiation. Dual nature of radiation is much more asked question, let me tell you. So have this is 2 or 3 paragraphs. You can easily get it and understand and write it down. So de Broglie concept is even easier. So Louis de Broglie has extended wave particle parallelism of radiation to matter. That means every material particle in motion is associated with a wave whose wavelength is inversely proportional to its momentum. There is an expression for de Broglie wavelength which you can actually have see in the notes and prepare. So matter waves also, if required, you can study, because anyway we have to study the entire unit. We need to cover all these parts. Let me tell you, choose 3 good units. So if you ask me, I would suggest you unit 1, unit 2 and unit 4. That's all. But if you say that you are already prepared for unit 3 and unit 5, that's fine, keep them, and one more unit you prepare so that you can answer. But unit 3 and unit 5, as we have seen already, we will be getting only 1 question each. So therefore we better prepare for the first 2 units better. Okay, so if you prepare first 2 units, so sufficient, you will be writing 4 questions. Now then we move on to the second unit. I would show you the second unit what we have. Just before we move on to the second unit, let me tell you Schrodinger wave equation is very much important. So Schrodinger wave equation, you need to derive this one, and the derivation looks very complicated, very tough, but it's not so. Just have a go through in the notes and also have a go through in the video that is available. I would show you here whatever the availability that is there. And this is the Schrodinger wave equation, which is very important. I am expecting Schrodinger wave equation tomorrow in the examination, the day after tomorrow. And then particle in a one-dimensional potential box. So there is another concept called as particle in a one-dimensional potential box. So this is regarding a microscopic material particle trapped in a small distance, in which it can move only one-dimensionally, say x direction. Then what will be the energy of the particle? Energy is exhibited by the particle. And what are the most probable positions of particles' presence in that small space? That will be given by this particular concept. So you can have a clear idea about particle in a one-dimensional potential box, and it is, if asked only, you need to write down. So generally he is asking us about the energy, so derive an expression for energy. So there is a question here, 8th question, if you just have a look at it. Derive an expression for the energy of the particle in a one-dimensional potential box of n, and then write eigenvalues and eigenfunctions. I would show you the answer now. Unit 1. Now particle in a one-dimensional potential box, as you can see the heading here, and so you would write this entire thing and up to how much part, so until here only. Understood? This is energy equation. And then you are asked also to write about the eigenvalues and eigenfunctions, that is this particular point, this one, 4th point. You can write all these 4 points for better understanding. That's it. So this is where you are going to get 8 marks. Understood how much part? So I would reduce the size to somewhere around 80, so that you would be knowing how much part you would be writing here. So write from here in this page up to here. Just study and write it, and that's it. And this is quite easier as well. You need not have to write the entire length of the concept unless you are asked to do. If you are asked to write most probable positions, so this part. Understood? This is how answer according to the question. Don't worry about anything. Right? Now, let me tell you what are the concepts that we can have questions, the numericals can come from the first unit. In the first unit, the numericals can come from, I would show you here. So can come from some of the concepts, and concepts like the de Broglie wavelength, concepts like the particle in a one-dimensional potential box. These two are very important. So particle in a one-dimensional potential box and de Broglie wavelength are the concepts. And now coming to the second unit, I would write the equations here. I would write the equations in the first unit. So what are the equations that we have the questions coming from? The numericals may come from. I would write the first equation is lambda is equal to h by mv. This is de Broglie equation. You can even consider it as h by p, where p is momentum. Another equation is lambda is equal to 12.27 by root v, where v is the potential. So this is for an electron only. So if you are asked to calculate de Broglie wavelength, this is de Broglie wavelength. Right? If you are asked to calculate, then only you would get it. So get all the equations for de Broglie wavelength. Lambda is equal to h by root 2 me, and so on, where e is the kinetic energy. Another equation where you would be getting problems is the particle in a one-dimensional potential box. En is equal to n square h square by 8 me square. This is the question. So he would be asking us to calculate So either E1, which is the lowest state, this is lowest energy state, n cannot be 0. So the least value of n would be equal to 1. When that is the case, En would be E1 and E1 is h square by 8 ma square. Mind you, h is Planck's constant, m is mass of the particle that is given. If at all electron is given, m will be 9.1 into 10 power minus 31 kg. A anyway would be, he would be giving us the value of A in angstrom units and also. So you can even calculate it in joules or in EV, where 1 EV is equal to 1.6 into 10 power minus 19 joules. That conversion you need to have if you are asked. So the first two excited states, if you are asked to calculate, you have to calculate E2 and E3, mind you. Last time around there was a problem asked on this particular equation that he wanted us to calculate the difference between energies of the first two excited states. E2 is the first excited state, E2 is the second excited state. These are the first two excited states. So he wanted us to calculate delta E. So for that you need to calculate E3 and also E2. So which is 9h square by 8 ma square. And this is 4h square by 8 ma square because n is equal to 2, n is equal to 3 in these cases. Now if you calculate h square by 8 ma square, which is E1, so E3 is 9E1. This is how you would calculate, right? Similarly E2 is equal to 4E1. Now this is how the problems that are going to come from unit 1 especially, right? Now moving on to unit 2, what are the questions that are important? What are intrinsic and extrinsic semiconductors? Distinguish between n-type and p-type semiconductors with an example. Now just let us go back to this particular question here in our unit 2. I would open. So what is semiconductor, intrinsic semiconductor? Expression for density of electrons in conduction band. This is for intrinsic semiconductor. And then there is a derivation here. Expression for density of holes. This is asked. Let us see what was asked in the last paper, previous paper. Let us see. Discuss Fermi level variation in p-type semiconductor with charge carrier concentration and temperature. This one is about extrinsic semiconductors. And what is the other question? IV characteristics of Zener diode. So both of them are from second unit itself. Let us see. Now this question from unit 2. So this is what he has asked us, the p-type semiconductor. So this is n-type, this is p-type carrier concentration, but we want the concept of Fermi level. So here how the Fermi level is going to shift? It would be available here. As temperature increases, the Fermi level would move towards the bottom of away from the top of the valence band towards the acceptor level, and then automatically it would move towards the intrinsic position, which would be exactly at the midst of the band gap. As temperature increases, the Fermi level would go down towards the top of the valence band and tries to get towards the top of the the intrinsic position, which would be at the middle. So that is given over here. So the derivation part, it is quite easy for you to derive, and even if you miss 1 or 2 steps, don't worry about it. So just remember the last 2 steps at least in that particular derivation. Now another question is regarding the junction diode. This one, the only question will be on the Zener diode. So I would show you Zener diode. So Zener diode is asked here in the last paper. So you can write the just IV characteristics. Draw the graph of Zener IV characteristics, and then you would be getting it. And here I would show you from our website, the Zener diode video is available. You can see that video and go for that particular understanding, and you can write it. So here I would be taking the concept of applied physics, and here there are topics. So you want me to open the second unit Zener diode, I would open it and I would show it to you. This is how it would be. I am now playing it for a while, just see. Dear students, and we will be discussing on xenon diode in our semiconductor physics section. So there will be audio also. What is basically a xenon diode? I think you would be getting that audio. A heavily doped silicon p injection diode designed to operate in the reverse bias in breakdown region is what we call as a xenon. The entire explanation of this one would come. This is how it appears. The difference between what is xenon diode and how it would be, what is the doping concentration, what is the difference between the xenon diode and available on both sides of the junction, the normal p injection diode, and all, you would have an idea about it. So you would be having these animations, you would understand them easily. So this is like a PPT video. So you'll be finding how xenon diode functions also as a voltage regulator. Then I'm going to use it's needless. So the question here is only about its characteristics. So you would have just an idea. This is characteristics. And so these are the characteristics you write down about the breakdown mechanisms as far as xenon diode is concerned. And the avalanche breakdown. We know that the reverse bias connection is so this is how the video would be available. You can go through that video. All the videos are available on our website. And the negative terminal battery moving further into the second unit itself, what are the questions that are being covered in the second unit in the previous exam? And we know that let us see Hall coefficient. There are an expression for Hall coefficient, and the next question is the bipolar junction transistor. Right. Now, so here the expression for Hall coefficient. Zener breakdown mainly occurs because of the second unit here. When sufficiently high electric field is applied across the p junction, what would happen is the covalent bonds would get broken across the junction, releasing more number of charge carriers across the junction. That is available again in our charge carriers to flow across the junction, making large currents as a video flowing across the p junction. If you want that. Similarly, when we talk about the avalanche breakdown, avalanche breakdown is a phenomena that is going to occur because of ionization of intrinsic semiconductors. That is also available in the second unit. Now, during reverse bias, getting the Hall effect, when the derivation of Hall coefficient and all pass through or come across the junction, they may collide with the intrinsic semiconductor move on to over there. The next unit here, thus eliciting first unit is over. Outermost shells. The second unit, what are the these questions that you can get so elicited would from be moving across unit, the junction, the problem and sections. This particular current would be very as far as the second unit is concerned, more and more number what are the important charge carriers, intrinsic and extrinsic semiconductors, a multiplication Fermi level due to carrier concentrations. Let me tell you, there exist 4 different carrier concentrations we have to come across. Which is called one is density of electrons in the conduction band blackbody radiation. The main density of electrons in the conduction band is as a voltage regulator. Density of holes in a voltage regulator power supply unit, the output is constant and is independent of density of electrons, density of holes, supply, and then concentration of p-type. Now we would see this material consisting of a xenon diode and across semiconductor, Btech being the xenon voltage, which regulates the unregulated DC V in and the input to the top V out across the load resistance. V out here would be constant irrespective of the changes in V in or even RL. Yeah, this is what are the concepts that you want to see. You can see say for example in unit 2, if you want to see Hall effect, just now we have discussed. So Hall effect is also available, you can see it. So that video is also available. Any particular video if you want to see in particular unit that you can have, and also the notes is available so in the website. Now I will be moving on to the third unit, because we are so not very much interested in our, we are going to skip the third unit. And if you want, you have everything in the for about third unit in the website optoelectronics, where you would be having direct and indirect band gap semiconductors, the transitions, light emitting diode, and the concept of it, the applications of light emitting diode, then photodiode, and then solar cell. So this is how the type photodiode types also you would have the avalanche photodiode and pin diode. These are the 5 topics. But if you prefer to have a very small unit, shall I close this one? Yeah, I would. Okay. Yeah. Okay. Right. Okay. Regarding the fourth unit, so what we have in fourth unit is lasers and fiber optics. So I was telling you about the third unit. So if you want to prepare in some time, and if you are concentrated enough, you can prepare the third unit in 3 hours, because you have only 5 topics in them. But don't gamble now. So I'm telling you openly that 1, 2 and 4 units you prepare and go to the exam. That's it. Right? Now lasers, you have interaction between matter and radiation. Let us see what are the questions that have come from lasers in the previous examination. Now in lasers we have solar cell. From third unit there are 2 questions. In fact, from fourth unit there is only 1 question. Third unit there are 2 questions. Fourth unit 1 question only. So sorry. Fourth unit question is from optical fibers. Acceptance angle of optical fiber and explain optical fiber as a dielectric waveguide. I would show you the answers for this. Now coming to the fourth unit here. So optical fiber, you may get questions from lasers this time. So what are the important questions from in fourth unit? Let us have an idea. Let us see. Einstein relations are important, that was asked, and then the components of laser and the types of laser. Ruby laser is there, helium neon laser is there, and CO2 laser is there. So these particular topics are again available to us in our website. You can go through each particular video, and these videos will not be spanning more than 10 or 12 minutes. That's it, or 15 minutes at the maximum. So you can have an idea about all of them, a clear idea, and you can even go through them number of times. So therefore it's quite easy for you to have a grasp, and you have a notes too with you for understanding of these concepts. So sorry. And what are the concepts that we have to study in unit 4? In unit 4, you have to study all 3 lasers apart from Einstein coefficients. What are the lasers that we have? We have ruby laser, which is quite regularly asked. What is ruby laser? Ruby rod would be there, and you need to understand the components of laser here. So laser is nothing but light emission, light amplification by stimulated emission of radiation. So there exists 3 processes: stimulated emission, spontaneous emission, and stimulated absorption, spontaneous emission, and stimulated emission. And there will be transitions as well. So just have a go through of these transitions. So when photon interacts with electron in the lower energy state, atom will go up. This is absorption. And this particular atom or electron that would be there in the higher energy state would automatically come back to its original state by leaving the photon it has already swallowed. This is what we call as spontaneous emission, and the time would be of the order of 10 power minus 8 seconds, what we call as lifetime. And then if the electron that is there in the higher energy state get to interact with the incident photon, then instead of going into further higher energy states, this electron would come down to its original state, or else the subsequent lower energy level, releasing another photon which is in phase with the first photon. In phase here corresponds to both of them would be maintaining the same, they will be coherent. So there will be 2 different coherences here. One is spatial coherence, the other one is temporal coherence. Both of them would be there for those 2 photons. I am talking about only 2. If at all there are 100 interactions, there will be 200 photons. And 1 crore interactions, there will be 2 crore photons. So that's why more the number of photons, more will be the intensity of the emitted radiation. That is what laser is. So you'll be getting the concept of laser and how the laser being emitted. The components of laser you need to understand here. How laser is produced. So for that you need to have the material, what we call as active medium, and then the second one is the pumping source. In order to excite the atoms to higher energy states and then get the de-excitation from them, we need to have a source to stimulate atoms to the higher energy states. That is what we call as a pumping source. So then the resonator cavity. Laser cannot be emitted under normal circumstances just outside, just like that. it has to come only in one direction. That will be taken care by an enclosure, what is called as a resonator cavity. So these are the ones. So these particular components would be there for every laser. For ruby laser, what is the active medium? The ruby rod, ruby metal, which is the combination of aluminum oxide and chromium 3+ ions. And what is the excitation here? The optical pumping. That means you would be having a light or a lamp glowing onto that particular material. Photons fall and the atoms get excited to the higher energy states. The de-excitations actually produce laser. And this will be enclosed in a cylindrical enclosure, which is not shown here anyway. That is the third component. Apart from that, you need to have the ELD, energy level diagram. That is very much important. You have to draw ELD for every laser. So we have ruby laser, we have helium neon laser. Similarly, helium neon laser, this is a gaseous mixture. You would be getting the electric discharge here. So automatically this gas is enclosed in a discharge tube. Discharge tube would be the resonator cavity, the active medium being the gas mixture of helium and neon, and then the pumping source would be an electric discharge. Now similarly, you would be having the energy level diagram, which you need to draw and showing the transitions from one level to the other level, which actually elicit laser. And for carbon dioxide laser, the same way, but you need to just also mention the transition from one particular mode of vibration of carbon dioxide molecule to other mode, like the asymmetric stretching mode, where carbon dioxide molecule would also move towards any of one of the oxygen atoms along the same line in a vibration. So which would be called as asymmetric mode. There will be symmetric mode and there will be bending mode. So changing from one mode to another mode releases amount of energy, that is nothing but laser. So this is about the carbon dioxide laser. So you can prepare for carbon dioxide laser. Apart from that, there is a semiconductor laser which you have in your third unit, but I have just furnished in the fourth unit. Semiconductor laser also you can prepare. If the question comes from the third unit on semiconductor laser, you can write down. If not, you just leave it like that. Okay, and then applications of lasers you need to have. Now coming to the second concept here on fiber optics, we have a question on how fiber optic material is going to behave as a dielectric waveguide. So this is what you need to write: the construction of optical fiber along with the diagram. Understood? And then this is sufficient. So if you write until here, so the construction part till here and the diagram part and then this part also, that is sufficient. If you are asked to derive an expression for acceptance angle, you are very lucky, because this is quite easy. You need to draw a diagram here like this. This is the diagram. You have to understand that a ray would come and fall on the core of this particular, this is the core part. This is the diagram I am talking about, and core of the fiber, and it would refract into the core medium and it would fall on the core cladding interface. So it would graze along the interface. Graze means it will move along the boundary. Then this theta naught is what we call it as, that is there here at the outside, is what we call it as acceptance angle. You have to derive an expression for acceptance angle. Now the questions, in fact, let me tell you, so there will be definitely a problem. If at all he gives a problem in the fourth unit, it would be on acceptance angle or numerical aperture. Let me tell you very clearly. It would be either on acceptance angle, which is sin theta naught. Theta naught value would be given, you have to calculate sin theta naught, which would be acceptance, or else you have to calculate acceptance angle by means of this formula. You will be given N1 and N2, which are the refractive indices of core and cladding, and N0, which is the refractive index of the outer medium. Generally this one would be air. So therefore N0 would be 1. So you would be left with sin inverse of root of N1 square minus N2 square. So this is acceptance angle. Similarly, you can calculate the numerical aperture, which is sine of acceptance angle, that is this much. I would show you here. This is the sine of acceptance angle, which is numerical aperture. If you are asked to derive an expression for numerical aperture, this is what you need to do. And remember, this is quite easy. Go for this kind of questions. Let us see what he has asked here in our last exam. He has asked us about the acceptance angle and then dielectric as a waveguide. This time I am expecting a question on from lasers, because last time around he has asked from optical fiber. So expect a question from lasers. Possibly one of the 3 lasers he would give and a few applications of lasers like that. So you can expect that way, right? And the important questions are also mentioned in our website. There is a document. Now moving on to the second part of this, the fifth unit. Anyway, we will touch fifth unit, where you would be having dielectrics. So this is all about the fourth unit. So you may have types of fibers also, the step index, the grade index fibers, the attenuation, that means the loss of signal strength in while the light or electromagnetic wave passes through the fiber. So these are absorption losses, bending losses and scattering losses. And here, mind you, if you have got this question, draw this graph, remember this graph. And even if you falter, maybe the values on either side, don't worry about them, but this particular shape should appear. This is the graph I am talking about. Okay, if you get the question on attenuation, signal attenuation, that is loss of signal strength. And he may even ask if the question comes from fibers, right? Generally this time around we may expect a question from lasers, right? Prepare lasers well. Don't leave it for lottery. Let me tell you that way also, because we are preparing only 2 or 3 units. So let us have 1, 2 and 4 in our mind for preparation, right? So we move on to unit 5, where unit 5 would be about the electromagnetism and magnetic properties of materials, where you would have fundamental laws of electricity and magnetism, which are very, very small. Gauss law of electrostatics, Gauss law of magnetostatics, Faraday's law of electromagnetism, and then the Ampere's law of electromagnetism. So all these are very small laws. You would be asked about them. General question from this particular section would be, last time around he has asked equation of continuity. I will show you what he has asked in the 5th unit. So in R18 last paper, let us see. Explain one method to determine dielectric constant of a material. This is on internal field, let me tell you. And then discuss about electric current and continuity equations. Continuity equation. So this is what just I have shown you in unit 5. So this is the equation of continuity, very small one. So I has asked it for 8 marks. So just this is how you need to derive, very small. So I would make it some 85 small size. So this is equation of continuity from here till here. That's it. But most important part of this particular unit is about Maxwell's electromagnetic equations. Remember these equations, they are not tough, they are very easy. So you can write them down if you are asked to write. He will be asking both forms, integral form, that is here, and also the differential form, right? Remember these equations. These equations are quite easy to do. And next, coming to the dielectric properties, he would be asking us about the definitions many a time, either in dielectrics or in magnetic materials, like dipole moment, dielectric constant, or polarization, electric polarization. So these are small definitions. If you are preparing the 5th unit, you have to prepare these definitions, and apart from that, you need to also prepare other parts like internal field, which is slightly takes longer time to understand. If you understood it well, you can always interpret. Let me also tell you one thing that is between us, is that while doing a derivation, a bigger derivation like Schrodinger wave equation, something like that, if you are very good at that particular part, you can do it. So you have to do it once or twice on a paper before you do it in the examination. Don't study it like any other subject. That is mathematics. Mathematics has to be practiced. So you need to do on a paper. So therefore do it. Now coming to internal field and something like that, in this, so you have E1, E2, E3 and E4, 4 particular levels. So in Lorentz model, and if you are asked about one-dimensional array of atoms, which is called as Epstein model, that is this one. So there are 2 derivations, whichever. So if you prepare for the 5th unit, you can prepare, and in between, if you find it difficult to get the correct derivation, remember the last 2 or 3 steps. So you can skip those particular steps and write down those particular equations, right? And diagrams are important in this particular part. And most importantly, so you may be asked about the Clashes-Mossetti equation, or even you may get into ferroelectricity. So there may be questions coming from ferroelectricity. A lot of the questions that were asked till now from this unit, let us have a check. The fundamental laws of electromagnetism, derive equation of continuity, what we have seen just now. And then write Maxwell's equations of both integral and differential forms. That is also there, that I have shown to you. And then I have just told you about the definitions: dielectric constant, polarization, electric susceptibility, displacement vector and all. These are asked. And then derive an expression for internal field for cubic symmetry. Cubic symmetry means Lorentz model. So, and these are the questions that have been given from December 2018 till date. The last examination that was held was the supplementary in this November. Before that, so it was only the last November examination, because we have had a lockdown continuously for 9 or 10 months. So there were no examination before. So all these examinations would be having these questions coming by. Ferro and piezoelectric materials. So notes is available. In fact, videos are available. You can have a go through. You will have clear understanding. And then the classification of magnetic materials. This you can study easily. Dia, para and ferromagnetic materials. I would show you that in the notes. So this is about the ferroelectricity part. Ferroelectricity. And if you are asked to write about the barium titanate, then you write about barium titanate. This is separately given. So you can mention only up to here if you are asked to write about ferroelectricity. And if you are asked to write about piezoelectricity and their applications. Similarly, ferroelectricity and applications, that you need to write. And regarding magnetic properties, so study these definitions which are very important. And then the classification: diamagnetic, paramagnetic and ferromagnetic materials. There are 5 or 6 points, 8 points I have mentioned here. You can have 5 points correctly written. You can get complete marks. And then hysteresis, this is very, very important as far as examination is concerned. If you want to prepare from 5th unit only for very small 1 or 2 topics, prepare for this topic, hysteresis. And this diagram, mind you, this is very important diagram. So quite regularly asked a question. Let us go back to our important questions from this unit. We have, yes, the question number 6 is explain hysteresis in ferromagnetic materials. Hysteresis is a process in which the magnetization vector lags behind the applied magnetic field vector in a ferromagnetic specimen. That is what we call as hysteresis. So here I have written the lagging of magnetization vector behind the magnetic field vector in one cycle of magnetization and demagnetization is what we call as hysteresis. So if you have the idea and this particular diagram, then you can easily get marks. So this is about the 5th unit. This is all about the concept of all 5 units where we have come across. And you got the videos as well. I would be showing any particular video coming from 4th or 5th units. Let us say you want to have the video on ferroelectricity. I would show you that ferroelectricity video. Right now I am clicking on it. So one more time I need to log in. I would do it. And then ferroelectricity, I would do it. Regarding problems in this particular unit, you would be getting problems from dielectric section. And let me write also that particular part. In dielectrics, you would be getting problem in questions coming on the relation between these 3. This is the video I am talking about on ferroelectricity. So if you just click on, you would be having clear idea about what are the different points on ferroelectricity. Anyway, now let us go back to the problem areas of this particular unit. In unit 5, we would have problems coming from equations that are, one is B is equal to mu naught into H plus I, where B is magnetic induction or magnetic flux density. Magnetic flux density. And then H is magnetic field, applied field. This is applied magnetic field, right? And then I is intensity of magnetization. So this is also called as magnetization or intensity of magnetization. There is a constant here that in this equation. Just guess what is that one? Yes, mu naught. So what is the value of mu naught? Do you know? It is called as permeability of free space. Mu naught is equal to 4 pi into 10 power minus 7 in Henry per meter. So this is the equation, quite liable you will be getting a problem from 5th unit. And what are the other equations? This is from magnetic materials anyway. The dielectric part, you have dipole moment. Dipole moment is just a product, let me tell you. So this is from dielectrics. Dipole moment is mu, you would give it as, this mu is dipole moment, let me tell you. This is a product of charge and distance, right? Charge and distance. This may be asked. We used to have concepts like called as the polarizations. Now they are not there in the syllabus, so you won't be asked questions on them. So this is about 5th unit. Understood? So we have first unit covered, the second unit. If you want third unit to be discussed, so I would discuss the third unit on it. What are the questions coming from the third unit so far? Recombination mechanism in semiconductors, I would show you. So how would be the third unit here? So this is second unit, sorry. And regarding unit 3, so you will have recombination, working of semiconductor laser, that was as I furnished already in the 4th unit. You have photodetector and the principle of operation, and then solar cell with the neat diagram, efficiency and fill factor. I wanted to discuss this one, but because, so yeah, if you want, I would discuss this solar cell anyway. I would show you this one from our notes section. We have yeah, this one. Solar cell is nothing but a material. It's a semiconducting material, in fact a PN junction that converts sunlight to the electricity with large conversion efficiency. Remember, the conversion efficiency will not be more than 30%. So even that is theoretical. To be precise, it would be 25% only. Anyway, so in which you would be studying about how the conversion would be. So now there is a difference between photoelectric effect and photovoltaic effect. In photoelectric effect, light is going to fall on a metal giving rise to current. In photovoltaic effect, light is going to fall on a semiconductor or a PN junction, which is anyway a semiconducting material itself, and going to produce current. That is the difference. Here you would be talking about solar cell and there will be photovoltaic effect only. In reverse order, light is going to fall on the PN junction, and at the PN junction there will be the charge carriers, both electrons and holes, in combination with by means of covalent bonding, and those covalent bonds get broken because of the photons that are coming from the light. The sunlight actually gives photons, and these photons would break those covalent bonds, creating charge carriers. So there will be current passing through because charge carriers are produced across the junction. So this is what we call it as the electricity because photovoltaic effect. Now as far as this particular graph is concerned, as you actually connect the solar cell in a circuit, initially when you have, even without any applied voltage, you will be getting current, the maximum current, or what we call it as, for zero voltage also you will be getting current, what we call it as short circuited current. That's when you short circuit means you will be taking all these sources out and connect by means of a wire both ends of the diode, you will be getting a current. That is what we call the short circuit current. And this short circuit current would decrease with increase in the applied voltage. And for a given value of the applied voltage, what we call it as open circuited voltage, that where you would be just taking that the battery out, open source out, then automatically there will be open circuit and the current straight away falls to zero. This is what we call it as open circuited voltage. The voltage for which the current becomes zero is open circuit voltage, and there is a product in fact of VOC and ISC, what we call it as maximum power. Power is a product of voltage and current. Here VOC and ISC is going to give us maximum the circuit current, and so here IM and VM are the maximum values that we can get in a rectangle that is drawn inside this particular area of the curve, and the product of these two is going to give us maximum power, and the ratio of this ISC to VOC to that of IM and VM is what we call it as the fill factor. I would write here what is meant by a fill factor. So fill factor is nothing but the ratio here. Sorry, one moment. So how to calculate fill factor? This question has been given, this problem is also given. I am just writing the formula Im into Vm divided by Isc into Voc. All these are available, just see this equation. All these are available in the graph itself. So he will give the values and wanted us to find out. He won't give the graph. But while furnishing this particular concept, you need to mention all these parameters and the graph also. You need to draw the graph. Right? So this is all about the concept of our revision class, and where you would be finding so I would open the third unit as I have told you. Yeah, this is third unit notes. You would have photodiodes also if you want to study, and this is a small unit. You can prepare and write definitely 2 questions from it. Let me one more time remind you that there will be 8 questions. 2 questions coming from first unit, 2 questions from the second unit, 2 questions from the third unit, and from 4th and 5th unit there are 1 question each. Understood? 2, 2, 2 from first 3 units. That means if you prepare first 3 units well, you are cleared the exam. So you'll be having 1 more question to write. 6 questions you can write. But if you want to leave one of the units, then study in any one of the 4th or 5th units. Okay? And getting marks is also easy, but you need to interpret it well. Draw the diagram with pencil neatly. Manage your time. Most important thing is manage your time. Select. So take 2 or 3 minutes or 5 minutes and select the questions that you are going to write, and have something in your mind, then start writing. Okay? Don't worry about the time. Start, write them down and finish them. Try to finish them in half an hour time. So maybe you will be getting 4 or 5 grace minutes at the end of the examination if you can bargain with your invigilator. But so the 2 hours is the examination time. That is how it is. Right? So this is all about the concept of revision class on applied physics. Hope you all get some understanding from this particular class and you do well in the examination. Wishing you all the very best, each and everyone who has attended this class, and so try to go through these particular concepts. And one more reminder for you is that so you can get all these videos in our website as I've just shown you, or even in your mobile phone itself in the app that is available, and at the same time the notes for all 5 units is available. You can have a go through. If you want to understand the concept better, so as to you can represent it better in the examination, you can have a go through of these videos. Let me tell you, each video is not more than, say this video is 18 minutes 36 seconds. So not more than that. So at the maximum of 20 minutes you will be covering every particular video. Select only a few videos, just go through them, have a clear look at them, and then study, and you will get easily the concept and more marks. Wishing you all the very best. Thanks a lot.